So now we're going to talk about section 1.7. I guess we can look at me for a minute while I'm setting this all up. Section 1.7 is going to be on the use of interval notation. And I'm not going to give you homework from this section because it's not really how I like the homework. It's where it kind of differ from how the book teaches this. Chapter 1 in this book is all a review. So this is one of the things in this class, since I've taught it so much, that students tend to need a refresher on. Maybe they've never seen it or they haven't seen it in a long time. So I decided to make sure to hit this every semester at the beginning. And we'll see it. Again, this is one of those, it's a notation thing now. It's almost like the language of math, right? This is a language of math thing that we're going to use all through this class. And if you've never seen it, it really is kind of goofy. And that's why I've decided to go over it. And if you have seen it, that's great. You can sit there and just be reviewed. Okay, so let's switch over to the document camera again. So 1.7, and what I'm going to focus on in 1.7 is the interval notation. Hold on, let me get to it's. Really, it's this chart that's on the top of page 184, okay? The chart that's on the top of page 184 is what I'm talking about because it brings them all together. So I'm going to make my own little chart like this. So this is interval notation. Ooh, I didn't spell it right. They call it interval notation. I'm going to call it set notation. They call it set builder. It's fine. It's not a big deal. And then lastly, a graph, which is just a line. Okay. So let's look at an example of this. And we're going to use this notation whenever we have more than one solution. Actually, not more than one. When we have an interval of solutions. So for instance, let's say I told you we had a solution that x could be anything greater than or equal to 2, okay? X could be anything as long as it was greater than or equal to 2. I'm not doing the same set builder that they do. That's fine. You have to put squiggly bracket x given x's. That's how they do it in the book. And this means x can be anything given x is greater than or equal to 2. Okay, it's a long way to say it. But if you're looking at the book, you'll see that their set builder looks more like this. Now, what does that mean? Let's graph it first. If we graphed it, we know forever to the left is negative infinity and forever to the right is positive infinity, right? And then somewhere along this line is 2. We'll put it there. So we got 2, 3, 4, and then dot, 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 we go to infinity. 1, 0, and then we have all the negative numbers, right? Now, you probably learned this. Now, your book uses brackets and parentheses. We'll get to that in a minute. You probably learned this with closed and open circles. And greater than or equal to meant you put a closed circle on the 2, right? Because we could be equal to it. And x can be anything greater than that. So x is going to be anything to the right. Okay, so this is how we would say this interval in set notation. This is how we would notate it on a graph. But in interval, it's a little different. In interval, we're going to use brackets and parentheses, okay? A bracket means we can equal the number. A parentheses means we can get all the way up to that number but never equal it, okay? So if we wanted to use bracket and parentheses interval notation for this solution, okay, for this notation, first we need to know what's the smallest, what's the furthest to the left this number can be. Well, the smallest it can be is 2, right? Because x is greater than or equal to 2. And it equals 2. So because it equals 2, we're going to put a bracket, okay? We're going to put a bracket there. So we're going to put bracket 2. And this means the smallest value our x can be is 2, okay? And it can equal it because it's a bracket. Now, what's the largest our 2 can be? Well, the 2 goes forever to the right. It goes to infinity, right? Not negative infinity, but positive infinity. And infinity is one of those numbers that doesn't even really exist, right? So because it doesn't exist, we'll always use a parentheses there. And it's because our line will always get closer and closer to infinity, but it'll never reach infinity. That's just how it is. Okay? That's just how it is. So I'm going to do another one of these, and we're going to tie this together just so you visually see. So look, graphing looks like this, set and then interval. These are all three the same thing, okay? Just notated three separate ways, okay? So let's look at another one. So x is less than, let's say like -1. X is less than -1. I'm going to put that on the graph. So we got negative infinity to positive infinity, right? I've got -1 out there somewhere. 0, 1, -2, -3, right? Just a number line. And -1's out there somewhere. Now, what's different about this one is we can't be -1, right? It's an open circle, okay? It's an open circle because we can't equal the -1. It's just a less than, not a less than or equal to. And it's a less than, right? And if you're wondering which way the arrow should go, your inequality, if you have x to the left, your inequality always tells you, right? Notice this arrow lined up with that arrow. This arrow means it's going to go to the left. Boom, okay? As long as x is to the left, that'll be true, okay? That'll be true. So notice the graph on this one's different. The x value can go forever to the left, but then it stops at -1. But it can't actually be -1. It can be all these numbers leading up to -1, but not included. So because of that, now we're going to use the parentheses on the negative infinity, right? The smallest this can be is negative infinity because it goes forever to the left. And the largest it can be is -1, but we need to use a parentheses here because we can't actually equal the -1, okay? We can't actually equal the -1. Kind of neat stuff, okay? And again, this is just the language of math, right? These are three different ways to say the same thing, okay? Three different ways to say the same thing. But in this class, we're going to use interval notation. We're going to use this column, okay? I wanted to just show you this, especially if you've never seen it before. Okay, so what if x could be like in between two numbers? Like let's say x was between 2 and 5. Okay, x is between 2 and 5. Now notice we got to be careful on what we can be equal to and what we can't be equal to. I'm going to draw the number line again. This one, all that really matters is 2 and 5, right? We're not going to go above or below it. We can be equal to the 2, so I'm going to do a close circle here. We can't be equal to the 5. So I'm going to do an open circle there. So it looks like this. But what that means is I'm going to use a bracket here on the closed circle and a parentheses on the open circle. So if you look at this, look, x can be anything between 2 and 5. So the smallest my x can be is 2. That gets a bracket because we can equal it. The largest my value can be is 5. Okay? The largest my value can be is 5. So it's going to get a parentheses. Okay, it'll get a parentheses. Okay. Now, another very common thing that's going to happen, actually pretty quickly in chapter 2, when we get to it, is that x can't equal a value. So it'll look like this. X can be anything as long as it's not, let's say, 3. Okay? X can be anything. It just can't be 3. So I'm going to show you what that looks like on a graph. X can't be 3, right? So it's got an open circle because we can't equal it. But look, we can be all the numbers to the left of 3 or to the right of 3, okay? We can be all these numbers to the left of 3 or the right of 3. All we're saying is that x can't be 3. It can be anything else it wants to be, okay? And what happens here is we have two separate intervals. We've got this interval to the left of 3, and then jumps right here, right? And then we have this interval to the right of 3. So if we're going to notate this, we actually have 2 separate intervals. We're going to notate this left interval first because you always go from smallest to largest, okay? We're going to notate the left interval first. So let's just look at this left interval. Well, our x value can go from negative infinity to 3. That would be that left interval. So negative infinity, remember infinities always get parentheses. We're going to go to 3. We can't equal 3, right? It tells us blatantly we cannot equal 3. So we're going to put a parentheses. Okay? Now, if our x can be in more than one interval, we use a math notation of a union. And a union means or. Now, how you write a union is a U without the stem. Okay? That means union. And then we're going to do the other print, or the next closest interval, I should say. So the next closest interval would be, well, 3 to infinity. Okay? 3 to infinity. Okay? So negative infinity to 3 and then 3 to infinity. So what this means is that x can be anything in this interval or this interval. That's what that means. Anything in from negative infinity to 3 or 3 to infinity. Okay? Pretty cool stuff. That's what this means. Okay? That's the what is this? What is this? How would you interpret this? X can be anything from negative infinity to 3 or 3 to infinity. Okay? Now, we'll even get some that x can't be 2 different values. Let's say x cannot be 1 and x cannot be 4. Okay? So let's look at this. This will be the last one we'll look at. And then really we'll see them later on in the wild, okay, when we're doing work. 2, 3, 4, 5, 0. Now for this one, x can't be 1 and x can't be 5. But it can be anything else. Now notice, with this example, we have 3 different intervals. We've got to the left of 1, in between 1 and 4, and greater than 4, okay? So I've got to make 3 different intervals, and we have to go smallest to largest. We have to go left to right, okay? So I got to write this a little smaller. Negative infinity to 1, union, and then I've got to do the in-between, okay? The good part of the Oreo. 1 to 4, and then union 4 to infinity. Okay, so this is how we would write this in math notation. Questions, comments, concerns? There's no homework for this. I'm not giving you any homework, okay? I just want you to have seen this because we're going to use it. And of course, once we start using it, you can ask questions. Don't be afraid to ask questions, okay? But that's what I wanted to go over in this section. Okay, I'm going to switch it over to me. You 3 that are in here, are there any questions? Do you guys have any questions about the lecture today? If you got a question about the class, feel free to ask as well. I don't mind going over anything, but I want you to have watched the introduction first. If you have not watched the introduction, hold off on your questions. Watch the introduction from yesterday from last class. And then if you have any questions after watching the introduction, please let me know. I am going to remind you that you have to have your final scheduled before test 1. Okay, your final's got to be scheduled before test 1. Test 1, I believe, is a week from today. I think it's next Tuesday. I could be wrong on that. So if you're in this second 7-week spring 2021 class, if you're not watching this later on, you've got to have that final scheduled already for me. Okay. Any questions before I let class out?
When do we need the TI-84 by?
Jesse, I would get it as soon as I could because it's going to make your life a little easier in the next few sections. but I know we will be using it more in chapter 3. It's
Okay.
like 3:1, 3:2, 3:3. In those sections, we use it more. And then in chapter 4, we have you pretty much have to have it by chapter 4. Yeah.
Okay. I'll work on getting that as soon as I can.
Yeah. Let me know. And when you find one, let me know where you find it and the price, because I just kind of like to keep an update on how much. Now, of course, if you buy it from an individual, that's different. But if you find it online, just shoot me the link if you don't mind.
All right. Sounds good.
Thanks, sir. Great. Okay. Well, I will see you all.